Hello everyone, welcome back to my Chem Corner. In today's video we're going to talk about salt analysis, which is a part of your chemistry practicals for grades 11 and 12. So this is going to benefit both the classes, which is first and second PUC. And before we move into the video, if you're new here, please do subscribe to the channel and hit the bell icon so you receive new notifications as and when I upload my video. So let's move into understanding how to conduct practicals. So in this video I'm going to talk about four things that are to be taken care of when you do your salt analysis practicals. One is the preliminary test. Now what is the meaning of a preliminary test? Is when you get your salt, what is that you observe physically? You're talking about how the salt looks like, or you're going to talk about the color of the salt. So those come under the preliminary test. Another thing that you will look into under preliminary test is the solubility of the salt. In what solvents can you dissolve your salt to get a homogeneous solution? Now after you do your preliminary test, the next thing that you'll be looking into is detection of acid radical. Basically you're looking at the negative part of your salt, which is the anion. There are series of steps which we will follow systematically to analyze the acid radical. Similarly, you will also be detecting basic radical, which is the cationic part of your salt. We will do procedure systematically to determine the basic radical. After all this, any experiment that we conduct, we need to write this result. So I will show you the result table also, how you can write it down. So first thing, let's look into your salt. Now whenever we get a salt in the lab, there are two different types of salt that we've learned, or solids, which is the amorphous salt. The other one is crystalline salt. Now amorphous salt is something like a talcum powder. When you touch it, that salt is going to stick onto your hand. It doesn't go off so easily, and when you touch it, it will feel like chalk powder. It's quite moist also. Whereas if you look at crystalline salts are more crystal in nature. When you touch them, you would feel like a table salt. You can feel the crystals whenever we take the salt. So that is your amorphous and crystalline salt. Now please remember, whenever we have an amorphous salt, it is going to be soluble in dilute HCl. You try to dissolve your amorphous salt in water, it will only give you a precipitate or a whitish solution. It's never going to give you a clear solution. So amorphous salts are always soluble in dilute HCl, whereas crystalline salts are going to be soluble in water only. So this is just a brief outline of your how the salt looks like. Now let's see how to do the preliminary analysis. Now when you write preliminary analysis, three things that you look at is state, color and solubility. Now state of the salt is either crystalline or they're amorphous, and I told you how to detect it. You always have to take a pinch of salt to find out whether they're crystalline or amorphous. Color of the salt is always white. We don't give any other salts. No colored salts will be given to you except for one that looks pale pink in color, but majority of your salt are white in color. Solubility of your salt, if it's crystalline salt, it has to be soluble in water, and if it is an amorphous salt, it will be soluble in dilute HCl. So accordingly we can write it. So now that we know how to do preliminary test, we need to move into detection of acid radical, which is the anion. Now under this we have to draw a table which says experiment, observation and inference. So whatever we are going to do, we are going to write it or record it in a table format only. So like this, we draw three tables, which is experiment, observation and inference. Now we are going to start with detecting group 1 acid radical. So group 1 acid radical, what are the reagents you are going to add? You take a little bit of salt, probably a pinch of salt, and you're going to add dilute HCl to it. If you have your salt, your radical in group 1, then you should have this particular observation which says brisk effervescence. Now what do you mean by brisk effervescence? When you open a cool drink bottle, you would see a fizz, right? The gas coming out. So that is what you're expected to see the minute you add dilute HCl. Now when you have brisk effervescence, obviously it is releasing some gas, a colorless, odorless gas. The minute you add dilute HCl, what do? You need to place a test tube which is wet, inverted on the other test tube. Now what happens is you're trying to collect gas in it. Once you collect gas, when you add lime water to the test tube that you collected the gas, your lime water will turn milky. So when you get this sort of an observation, the inference is going to be that you have group 1 acid radical present. It may be carbonate, CO3 2-, that is a radical present. So this particular test is actually the group test to tell us that particular group is present. Now to confirm further that a radical is present, what you have to do is you need to do a confirmatory test for it. Now confirmatory test for group 1 is named as lime water test. So what you do is, to this you take salt and water. Basically you prepare salt solution, you boil it, and then you pass the vapors to a test tube that's containing lime water. You shake it well. Once you shake it, lime water in this case does not turn milky. Now why is it that it does not turn milky in this? Please remember, you have added water, and water will not allow the gas to be displaced. And because of that, lime water will not turn milky in the confirmatory test. So in this case, carbonate ion is confirmed. When it doesn't turn milky, that means carbonate ion is confirmed. Now this is what you do if you have a group 1 acid radical. But what if you don't have a group 1, which means when you did salt and dilute HCl, there was nothing seen at all. There was nothing at all. So then what do? You move to your next group, which is group 2 acid radical. So in this group 2 acid radical, you take a salt in a dry test tube. For group 2, please remember, you need to clamp your test tubes to a test tube holder, and you should have a dry test tube, because you're going to add concentrated H2SO4. You have to be very careful. Now when you add these two, there are two observations that you can see. The first observation is you get vigorous reaction liberating colorless odorless gas, which will give dense white fumes when a glass rod dipped in NH4OH is exposed to the mouth of the test tube. Now when you see the very first big reaction over here, that particular observation is for a chloride ion. But at the same time, you may get another type of a observation, which is white fumes followed by brown fumes. In this case, you will get a bromide ion. So you need to be careful. You need to always observe your test tube to see what sort of a fume are you getting. If you're getting dense white fume, it is chloride. But if you get a brown fume, it is going to be bromide. Now, what if you don't have any of these two observed in your test tube? You added salt, you added concentrated H2SO4, you did not observe any fume. Do not discard it. To the same test tube, you will add a copper turning or a paper ball, and you have to heat it. Now when you do that, you will get reddish brown fumes observed if you have nitrate present. So here in group 2, you have three possible radicals. One is chloride, bromide and nitrate. Depending on what observation you see, you are going to do further confirmatory test for that particular radical. Alright, so we will move to confirmatory test for individual radicals now. So the first confirmatory test is for chloride. The test is named as chromyl chloride test. Now in this case, what are you doing? You take salt plus K2Cr2O7 crystals, which is potassium dichromate. It will be orange color crystals. To that, when you add concentrated H2SO4, you will have orange red vapors coming out. You pass this vapors to a test tube that contains NaOH solution. When you pass it, what happens is when you shake it well, you will get a yellow solution. To this yellow solution, when you add acetic acid and lead acetate solution, you will get an orange precipitate. Now this will confirm a chloride ion. Now in your exam for PUC, none of the examiners are going to ask you to perform this. We don't perform. But if you get a chloride ion in your group test, you should write this procedure in your paper. But we don't perform it. Instead, we have one more test to perform for chloride, which is silver nitrate test. For this, what do? You prepare a salt solution. How do you prepare a salt solution? You add salt and water. To that, you are going to add silver nitrate solution. Few drops are more than enough. Now when you add these two, you will immediately get a curdy white precipitate. When you add NH4OH, that curdy white precipitate is going to be completely soluble. Alright, now this will confirm chloride ion. So there are two confirmatory tests. You are expected to write both the confirmatory tests if you get chloride as your radical in the group test. But out of the two tests, no examiner will ask you to perform chromyl chloride. They will only ask you to perform silver nitrate test. So that is your confirmatory for chloride and chloride, two confirmatory. Now say when you did the group test, you got bromide. So the confirmatory test for bromide is globule test. Now in this one, what do you take? You add salt solution. Salt solution is just salt and water. To this you add chlorine water and a few drops of CCl4 and you shake it nicely. Now when you shake it nicely, initially before you shake, you might form some globule, but that globule could be placed or probably say yellow in color or orange in color. When you shake it well, that globule will change to orange-red globule. That is when you confirm the presence of a bromide ion. Another test that you can perform is again silver nitrate test for bromide. Now in this case, the procedure is same as how you did for chloride. But there is only one difference in the observation. In chloride you got curdy white precipitate. In this case for bromide you get pale yellow precipitate, which is sparingly soluble in NH4OH. What about chloride? Chloride was completely soluble in NH4OH, whereas for bromide it is going to be sparingly soluble. So these are the two confirmatory tests for bromide. Both of this can be performed in lab. Both of it can be written in your paper. Now when you did the first group test for chloride, bromide, nothing was there. But when you did for nitrate, you got nitrate positive. So for nitrate, you have only one test, which is brown ring test. For this, what do? You take salt solution. You add equal amount of freshly prepared FeSO4. We don't use FeSO4 which is old or prepared and kept for a quite long time because it will get converted to Fe3+. It won't be effective. So we always prepare freshly prepared FeSO4. Once you do this, to the sides of the test tube, carefully add concentrated H2SO4. Now because you're adding concentrated H2SO4, you need to use a test tube which is clamped to a test tube holder. It should be done very carefully. Without shaking, when you add concentrated H2SO4, easily you will get a very nice brown ring at the junction of two liquids. That is when you confirm that you have a nitrate ion in your salt. Alright, so now if you don't have group 2 at all, when you did salt and concentrated H2SO4 in your test tube for group 2, you did not get any observation. You did not get for bromide, you did not get for chloride. When you add a copper turning and you heat it, you do not get for nitrate also. Then what do? You skip the entire group 2 and you go to the last group, which is group 3. So after group 3, what do you get? You have to add salt solution. Salt solution is just salt in water. To that you are going to add barium chloride solution. The minute you add barium chloride solution, you will get thick white precipitate. To that thick white precipitate, you are going to add excess of dilute HCl. Nothing will happen to the precipitate and the precipitate is going to be insoluble. Now this is going to be the group test as well as confirmatory test for sulfate. Therefore we say that group 3 acid radical sulfate ion is present and confirmed. Alright, so I hope this entire acid radical is clear to you all. One is detection of basic radical. So here the first thing is to test for group 0. In this case you take salt and dilute NaOH and you have to boil it. So in this case also you need to clamp your test tubes to a test tube holder. Now when you do that and when you smell the test tube, be very careful because the test tube will be hot. Pungent smell of ammonia gas is evolved when it liberates a colorless gas. Now what you will do is you take your glass rod, you dip it in concentrated HCl and expose to the mouth of the test tube. Now when you do that, whatever fume is coming out, it will be dense white. So then you are going to say that group 0 is present, the radical could be NH4+. So if you have group 0, then you need to, before you move into confirmatory, you need to prepare something called as original solution, because in acid radical you used salt directly. In basic radical you will use original solution. So how are you going to prepare that original solution? Your original solution that you prepare is going to depend on your solubility of the salt. If your salt was amorphous, you prepare your original solution in dilute HCl. If your salt is crystalline, since the solubility is water, you prepare your original solution in water. So when you do that, you are going to use that original solution for confirmatory test for ammonium, which is called as Nessler's reagent test. Now you take the OS, a little bit of OS, to that you add Nessler's reagent and dilute NaOH a little. When you add that, you will get reddish brown precipitate. You are going to confirm the presence of ammonium in this case. That is if you have ammonia present and if you get a positive test. What if you add salt and dilute NaOH and boil and you don't get anything? Then what you do is you move to group 1 basic radical. Now group 1 and group 2 basic radical is going to be absent for class 11 and 12 or for first PU and second PU because they contain radicals which require a separate procedure altogether. And they are more of interfering radicals, they are more of cations which are bigger in size, so their procedure is different. So we are not going to do group 1 and group 2 at all, but we need to write the procedure in our record books and observations. So for group 1, we need OS plus dilute HCl. There is no precipitate. When you move to group 2, the same reagents as group 1. Only thing is you add extra H2S2. We need to write the procedure in your book, but we will not perform it. So after group 0, we directly move into group 3. For group 3, you take a little bit of OS. You add NH4Cl solid, which is your salt. Half a spatula. You mix it well. Once you mix it thoroughly, then you add excess of NH4OH. Now you will add NH4OH only after dissolving NH4Cl solid. Because of common ion effect, it is not going to dissolve after you add NH4OH. So completely dissolve NH4OH, only then add NH4Cl, only then add NH4OH. Now if you get a positive test in this, you will get gelatinous white precipitate confirming the presence of group 3 basic radical, which is Al3+. Now if you have Al3+, you have a confirmatory test for it. The first confirmatory test is you take OS and dilute NaOH. You add a little first. When you add little first, what will you observe is you get a gelatinous white precipitate. If you add excess of NaOH, that entire white precipitate is going to get solubilized and you get a clear solution. To this clear solution, you add NH4Cl, you boil it well, you cool it under tap water. When you cool it nicely, that white precipitate that you got in the first test is going to reappear and you confirm the presence of Al3+. So that is the first confirmatory test. You have one more confirmatory test for Al3+, which is a blue litmus test. You take your OS and you add blue litmus solution to it with few drops of NH4OH, you will get a nice blue floating mass in the solution. That is going to confirm Al3+ ion. Now what if you did your group 3 group test and you did not get any precipitate at all? Then what do? You move to group 4. Now for group 4, if you see, the common reagent here is the group 3 reagent. You are adding extra H2S to it. When you add H2S, there are two possible observations you can see. If you get a dirty white precipitate, you're confirming zinc. If you get a buff or a flesh color precipitate, you're telling that you have Mn2+. Now, depending on what observation you get here, accordingly that particular radical, you will do a confirmatory test. So the first one is confirmatory test for zinc. You take OS and you add dilute NaOH to it. The minute you add dilute NaOH, you will get a white precipitate. When you add excess of NaOH, that precipitate will be completely soluble. Okay. Now when you get this particular observation, you get Zn2+ confirmed. So that is the very first step. But you have another confirmatory test for Zn, which we normally don't allow children to do. But when you write it, you have to write it down in your test. You take OS and you add potassium ferrocyanide, which is K4FeCN6. When you add these two, you will get a bluish white precipitate, which is confirming the presence of Zn2+. So these are the two confirmatory tests for Zn. Now if you get a flesh color precipitate in the group test, you will do the confirmatory for Mn. So Mn and Zn, the first confirmatory is common. You take OS and dilute NaOH, but the observation is slightly different. In both you get a white precipitate, but for Mn you get that white precipitate and you just leave it there for some time. That white precipitate will slowly turn brown color. Now that is going to confirm the presence of Mn2+. So that is for Mn. Now you have another Mn test, which is permanganic test, acid test. To this you take OS, you add a pinch of PbO2, lead oxide, which is a black color salt, and you add 1 ml of concentrated nitric acid. When you add all of this, you clamp your test tube to a test tube holder, boil it nicely. After you boil it, you cool it and you add little water into the test tube. Once you do that, you leave it there for some time. You will slowly see that the precipitate has settled down and you have only a pink color supernatant solution on top. Slowly transfer that entire pink solution without disturbing the precipitate, and that process is called as decanting the solution. When you do that, the other test tube will contain pink supernatant solution, which is conforming Mn2+. So when you do all of this and you don't end up getting any positive test in the group test, which is for group 4, you will leave the entire group 4 and move to group 5. So in group 5, what do you observe? The group 3 reagents are there. Extra, you're adding ammonium carbonate. When you get a positive test, you will get a white precipitate telling that you have, it could be barium, strontium or calcium. So in this group itself, you're not going to determine whether it's barium or strontium or calcium. So individually, you have to do the confirmatory test. So for this, for barium, you need to take your OS and add K2CrO4, which is the potassium chromate. In this, you will get a yellow precipitate if it's positive and you're confirming Ba2+. Now, apart from this, you can also do a flame test in group 5. For this, you need to take your salt, you add a little bit of concentrated HCl and make a paste. Using your pencil lead, just take a little bit of the paste and introduce the flame. If it is apple green in color, then you're telling that you have Ba2+. So that is a flame test for Ba2+. Now to do for strontium, you take your OS and you add ammonium sulfate to it. If you get a white precipitate, that means strontium ion is confirmed. For this, again, when you conduct the same way flame test, you will get a crimson red color, which is a shiny red color. Then you say strontium ion is confirmed. If you don't have strontium, also you do the test for calcium, which is you're adding ammonium oxalate to OS. You will get a white precipitate which confirms calcium. And for this, when you do the flame test, you get a brick red color, which is confirming the presence of Ca2+. So these are your confirmatory tests for radicals in group 5. Now when you did group 5 also, you did not get anything. So what do? You move to your last group, which is your group 6. Again, for this, you take your group 3 reagents and you add ammonium phosphate. You will get a white precipitate, which is confirming the presence of Mg2+, which is a group 6 basic radical. You don't have a separate confirmatory test for group 6. So you just say group 6 basic radical is present and confirmed. So this is the entire radical that you have in acid radical as well as basic radical. For acid radicals, we have totally 3 groups. Under that, group 1 has carbonate, group 2 has chloride, bromide and nitrate, group 3 has sulfate. For your group basic radical, group 6 is going to be ammonium. Group 1 and group 2 we don't have at all. Group 3 has aluminium. Group 4 has zinc and manganese. Group 5 has barium, strontium and calcium. Group 6 has magnesium. Now once you have detected what your acid and basic radical is, you write a detailed result table. Now result table, I am just showing an example here. You can mention acid radical here. You can mention the basic radical and the salt in terms of formula as well as words. So this is just an example here for the salt analysis. So this is just a entire general procedure how to conduct salt analysis. Upcoming videos, I will be slowly putting up individual procedure for each salt that is there in both first and second PU syllabus. So I'll see you in my next video. Stay tuned and thank you so much for watching.